For decades, the scientific narrative surrounding Mars has remained relatively consistent. It was seen as a dry, frozen planet, cloaked in rust-colored dust and swept by fierce winds that howl across a lifeless landscape. Popular science told us that Mars may have once held water, billions of years ago, but whatever oceans or rivers it held had long since vanished. The prevailing image was that of a barren world with little more than dry channels and craters to suggest a wetter past. NASA's rovers reinforced this picture. Mars had rocky plains and layered sediment, but none offered definitive evidence of long-term bodies of water. The idea that Mars once supported a large, stable ocean was seen as speculative at best and wishful thinking at worst. The conversation around Martian habitability remained focused on isolated traces, mineral deposits here, a patch of salt-rich soil there, nothing conclusive enough to rewrite the textbooks. China, however, was not content with repeating old assumptions. While Western space agencies continued to search for signs of microbial life through ambitious sample return plans and drone-powered exploration, Beijing adopted a more deliberate strategy. Rather than chase headlines, China chose to quietly observe. They began by sending the Tianwen-1 mission to orbit Mars, and then in 2021, they did what few expected. They successfully landed a rover named Zhurong in a region called Utopia Planitia. It was not the most glamorous of landing sites, and global headlines barely paid attention. While the world marveled at helicopters flying in Martian air and robot arms collecting rock cores, Zhurong simply began its work. Day after day, it scanned the terrain. It collected images. It probed the ground with radar. It monitored the wind and analyzed the chemical makeup of the surface beneath its wheels. And all the while, it listened quietly, carefully, and patiently. After nearly 3 years of silent surveying and deep soil scanning, Zhurong's mission now speaks volumes and has yielded data that challenges the foundations of what we thought we knew. At first glance, the site where Zhurong landed appeared unremarkable, a broad, level plain covered in reddish dust and scattered rocks. But that dusty stretch of land would soon become the most geologically revealing patch of real estate on the entire planet. Hidden beneath its deceptively still surface was a layered archive of Martian history, and China had just rolled a scientific detective across it. Zhurong was not just a camera on wheels. It carried a suite of instruments tailored for deep discovery. Most significant among them was a ground-penetrating radar, developed from technology used during China's lunar missions. The system actually has 2 channels, a high-frequency radar that scans down to about 10 meters with high resolution, and a low-frequency channel that can peer deeper, down to 80 meters or more, allowing scientists to uncover buried secrets with unprecedented scope.
Agency's Martian rover Zhurong.
Every meter Zhurong traveled was a data-rich journey. The radar began identifying horizontal layers and ripple patterns in the soil that mirrored those found along Earth's ancient shorelines. These were not formed by wind or landslides. They were too regular, too consistent. The shapes resembled underwater sandbars shaped by tidal movements, indicating that water had not just visited this place, it had remained. The patterns extended in multiple directions, showing changes in current over time. These were not the relics of a flash flood. This was the sediment shaped by sustained wave activity. The deeper Zhurong scanned, the more complex the story became. Layered mineral formations were discovered, specifically hydrated sulfates and carbonates that could only form in the presence of long-term liquid water. Some were stacked like geological timestamps, suggesting different periods of water presence, receding and returning like tides over millennia. These observations began to support a larger theory. Utopia Planitia, once dismissed as a boring impact basin, was revealing itself as a probable ancient ocean floor. Zhurong had not just found traces, it had found structure, data, and direction that provided compelling evidence for this hypothesis. The discovery of these formations, which strongly resemble Earth's coastal deposits, has led many to conclude that an enormous body of water once existed here. While previous missions had hinted at this, Zhurong was the first to show it from ground level with confirmable scans and imaging. That meant that Mars had more than water. It had shorelines, a hydrological cycle, and possibly stability, the kind of environmental consistency that life requires. The mission's success makes one wonder how China managed to pull this off, who was responsible for building the rover, and perhaps most importantly, why no one saw this incredible achievement coming. To unlock what Zhurong found, we need to trace the path of the machine that made it possible. In July 2020, China launched the Tianwen-1 mission, a bold, triple-module spacecraft consisting of an orbiter, a lander, and a rover. No country had ever attempted all three components in a maiden Mars mission, but China did not just attempt it, they succeeded on the very first try.
Understandable apprehension among Chinese scientists.
By February 2021, Tianwen-1 had entered orbit around Mars. Just a few months later, in May, the Zhurong rover detached from its lander and touched down on Utopia Planitia, a wide basin in Mars's northern hemisphere. While most Western rovers targeted regions closer to the Martian equator, China deliberately went farther north, into a site believed to have once held water. It was a calculated gamble, but it paid off. Zhurong's design reflected China's emphasis on self-sufficiency. It weighed about 240 kilograms and operated on solar power, with folding panels designed to shake off dust accumulation. Its core systems were not copied from NASA, but built from the ground up using China's own advancements in deep penetration radar, honed through years of lunar research during the Chang'e missions. The same radar technology, upgraded for Martian conditions, allowed Zhurong to see what other rovers had missed beneath the surface. Zhurong's meteorology suite measured temperatures, wind speed, and pressure. Its terrain navigation system enabled it to travel more than 1,900 meters across varied topography, farther south than many previous landers had dared to go. And it did so while sending back high-resolution imaging, atmospheric data, and chemical signatures, all from a region few had considered worth the effort. What made this achievement so effective was not just the hardware, but the mission strategy itself. While Western agencies raced to innovate eye-catching technologies like drones and robotic arms, China focused on reliability, efficiency, and long-term data collection. There was no over-engineering or desperate rush for press coverage. There was just science. One quiet rover traveling across the forgotten plain, building the case for the most astonishing revelation of the Martian age. And now, the results are no longer buried under Martian soil. They are sparking debate across laboratories, conference halls, and space agencies around the world. The discovery did not stay buried in Beijing's data vaults for long. As Zhurong's ground-penetrating radar readings and sediment analysis entered the global academic bloodstream, reactions began to ripple forward. Quiet interest turned into widespread recalibration because of a credible piece of evidence pointing to a standing body of water on Mars. Planetary researchers across Europe and North America began reassessing old assumptions. Regions that now were previously written off as geologically uneventful were placed back on the table. The mineral stratification, the ripple formations, the radar depth readings, these were no longer curiosities. They were potential proof points. As the ripple effects intensified, space agencies that previously favored regions like Jezero Crater began pivoting. Quietly but decisively, mission planners were reassessing attention to the Martian north. The possibility That Zhurong had uncovered part of a planetary shoreline reshaped how future explorations would be planned. Even more telling was the science surrounding the discovery's release. Instead of a high-profile press event, the findings were quietly published in scientific journals with raw data made available to the public. This approach, which observers interpreted as a deliberate strategy, spoke volumes. For many space policy analysts, it was not just a scientific moment, but also a geopolitical signal, demonstrating China's confidence and a shift in how it engages with the international scientific community. And as the implications took root, so did the awareness that Mars science had a new power center. Zhurong's ripples were no longer confined to Martian dust. They were moving policy, missions, and minds right here on Earth. Zhurong's success was never intended to stand alone. From the outset, China's Mars program was part of a broader roadmap, and now that roadmap is accelerating. Beijing has already announced plans for a Mars sample return mission scheduled for 2028. If that timeline holds, it would beat the NASA ESA joint mission by 2 full years. In a field where every day matters, this head start is strategic. The proposed mission architecture is strikingly autonomous. Rather than rely on long command relays or joint operations, China aims to launch, land, collect, and return material entirely with its own hardware. This includes an ascent vehicle, a return capsule, and potentially a Martian orbit rendezvous module. But the ambitions do not stop at soil samples. Internal planning documents and published roadmaps hint at something even more ambitious: the creation of a semi-permanent Martian research platform. This could evolve into a full-fledged Martian outpost complete with deep drilling rigs, compact nuclear or solar power units, and systems that mine the planet's own soil and atmosphere for fuel and oxygen. Such a platform would fundamentally change the dynamic of planetary science. It would move China from the role of data collector to infrastructure builder, from visitor to tenant. This shift is not happening in a vacuum. Space policy analysts have taken note of how China's expanding Martian operations could translate into influence, prestige, and potentially even resource claims. As the Moon and Mars become zones of scientific interest and technological investment, they also become theaters of geopolitical leverage. Mars is not just a red rock anymore, it's a red chessboard. And with every launch, China is moving pieces forward with purpose. The story of Zhurong and the ancient Martian Ocean is no longer just a scientific breakthrough. It is a paradigm shift with ripple effects far beyond the red planet. What began as a quiet observation mission in a forgotten basin has now evolved into something larger. A turning point in how humanity imagines, plans, and contests the future of space exploration. Every new layer of sediment uncovered by Zhurong has not only reshaped the Martian timeline, but also pushed other nations to revisit what they once dismissed. With China's plans for a sample return in motion, the traditional space powers find themselves scrambling to recalibrate. It is no longer enough to simply explore. The emphasis is now on permanence, infrastructure, and strategic positioning. If China succeeds in building a returnable system or in deploying reactors that can process Martian resources on site, the balance of power in space science and aerospace capability could shift dramatically. The country would not only own key scientific data, it would also master the logistics of staying on Mars longer, going deeper, and extracting more. This leads to a larger question. Who writes the next chapter of human space history? Is it the nation that lands first? The one that builds longest? Or the one that listens closest to what a silent world is saying?
Scheduled to occur during the International
Mars, once was a place of fiction and fantasy, is now a silent battleground for influence. Not through weapons or flags, but through data, timing, and scientific precision. Every rover deployed, every core sample taken, every pixel of satellite imagery interpreted has become part of a deeper competition. And in the silent race, the leading edge now speaks Mandarin. What begins as ripple marks in Martian soil has now set off ripple effects across the entire landscape of planetary science. Zhurong's mission, once seen as a modest engineering trial, is now shaping international roadmaps for how we explore worlds beyond our own. The discovery of potential shoreline structures and stratified water-worn layers is not just a clue about Mars's past, it's a guide to where humanity might look next and how we choose to build the future of exploration. Sample return missions are no longer optional, they are essential, and China is preparing to be the first to bring Mars to Earth. If that mission succeeds, it would mark the first time Martian soil physically reaches human hands, not in theory or simulation, but in reality. And it will not arrive wrapped in a Western flag. It will be Chinese engineered, Chinese delivered, and Chinese analyzed. Other nations are watching closely. NASA and the European Space Agency are accelerating their own joint return program. Missions once planned for the mid-2030s are being fast-tracked. The silent lead taken by China has created loud reactions in boardrooms, laboratories, and launch pads around the world. But the real shift is not in timeliness, it is in tone. The Red Planet has changed in our collective imagination. It is no longer an empty stage, but a frontier with competing voices, overlapping ambitions, and global consequences. And the discoveries made there are no longer whispered across obscure scientific journals. They are announced with strategy, investment, and intent. The idea of life on Mars, once whispered on the edges of science, now stands on firmer ground. We are not just chasing shadows anymore. We are analyzing fingerprints, mapping ancient tides, and decoding the memory of a planet that may once have known water, warmth, and perhaps even something that lived. The quiet revolution of a single rover in a forgotten basin has proven that sustained, methodical inquiry can unlock secrets that the most ambitious, headline-grabbing missions might overlook. It has changed not just what we look for on Mars, but how we think when we get there. The Red Planet is no longer a distant, dead relic. It's an active frontier with history waiting to be decoded. If this breakdown left you stunned, make sure to subscribe and hit the notification bell. Let's journey through the universe together.